All right, so .NET is, we've been doing binary exploits at the assembly language level and languages like C and Rust. .NET is Microsoft's competitor to Java, so it's at a high level. So you put it in with Visual Studio 2022. You need to install the .NET option here, which is not installed on these machines. I didn't think of that when I made them. You have to modify the .NET that's already, the Visual Studio that's already installed, to add the .NET development environment to it, which I've done. It takes 5 or 10 minutes. And so then you can make a simple .NET app to see what it does with Visual Studio. And it's, get it going. Okay. Then create a new project. Okay. And now you have to carefully get the right one. Console app on .NET. There are a lot of options and a bunch of them look similar. So I want to go without signing in, which is possible somehow. Close this. Okay. There we are. And I need just that one. This is C++. That's no good. And I don't think I have .NET as an option, so we'll take all languages. Windows Desktop, Windows Forms app .NET. That might be it. No, console app .NET. Okay. After you've done it, it'll remember you're currently used, but before that, it's pretty confusing to find the right one. And Windows Form Control Library, Shared Product, Project. Man, it's harder than usual. Is there an option for console or something? Windows Desktop, maybe. Console? Nope. Desktop. How about this? Console. Console app. .NET. There it is. Okay. I said a bunch of them and it's easy to get confused. Okay. I think I've got the right one. We're going to find out. And then I just take all the defaults and it makes something. If I made it right, it's going to be just one line, console right line. All right, and there it is, console right line. Got a little bit more here than I expected. All right, let's see. This might be close enough. I'm not sure I got the exact option there, but I didn't expect this extra stuff here. But let's run this thing and see what it does. There it goes, building it, and still working on it. And here it is running in the command line. So it should print like hello world or something. There it is, prints hello world and stops. Okay, so it's pretty close to what I had before. All right, and all right. Now, I should be able to do string manipulations. Program.cs is what I expected, and I think I must have something else. I mean Visual Basic. Okay, that's my problem. I got to try again. Let's go make a new one. File, new project. Problem, .NET is Visual Basic, or this thing, Visual Studio, is extremely complicated. It has far too many options. So it's too easy to fall off the track. Console. Okay. Console app. And how do I tell? Here's the VB. Here's the C#. Okay. So I want this one, the C#. I think that's it. Let's try this one. That's the one. Just the one line. Okay. And that one, when you run it, it'll look the same as the other one, but it's closer to C. This is a C-derived language, and that's where we want to be for what I'm showing you here. So,
that's just in, that's already in the drive.
Well, in a drive, what?
That file.
Well, yes, it does save it. Every time you create something, it saves it in a deeply nested folder, as you'll see, in your home folder, yeah, in your documents. It's saving it here, C user, source, repos, console app, that's the path. It is creating a file for each one of these I make. So and here again it says hello world, and you can press a key to close this window. And now we can replace the code with some code here, which is going to be like what we've done before, string manipulations. So I Control A and delete to get rid of that code, Control V to paste it in. So now I have a short string, and it's going to read something from the user and then print it out again. And so I just run this one. Now it opens a window, and now I can put in stuff like hello, and it says you said hello. So that's not too surprising, but of course the interesting thing is to see if I can get an overflow. And so if I can put in a long string, and it just works without any overflow, because this is a .NET, this is not C#. I might have written C# code, but it is not compiling with the C compiler. It's compiling to .NET, and that's like Java. Now Java doesn't really compile to native machine code at all. It compiles to bytecode, which runs in a Java virtual machine. .NET compiles to intermediate language, which runs in a .NET runtime. It's all just the Microsoft version of the same thing, and that's what we're going to mess with. Because this is a high-level language, it does not have the flaws of C, but it does have another huge flaw, which is something that Android developers don't understand, which is for all practical purposes, you have the source code with every app, because the partially compiled stuff is very close to the source code, and it includes the labels of variables and methods and everything you need. Now you can, in fact, make it unsafe if you want to, but it's really hard to do. You have to tell it you're going to be unsafe, you have to compile it with unsafe code, and then when you compile it, you have to go into the compiling options and allow unsafe code. So if you really try, you can manage to get a buffer overflow, but it's not easy and it doesn't happen by accident. And by the way, you can do that in Rust too. You can say, I'm determined to use unsafe methods and add it in. But unless you go out of your way to do it, you're never going to get an overflow. Now, let's try a graphical project. This is going to be File New Project, and I need to find this one, Windows Forms app, C#. So let's try that one. File New, New Project. All right. And now I want Forms app. Maybe Forms will do. Okay. Windows Forms app, C#, .NET. I think that's it. I want this one that says C# and .NET. That looks pretty good. We'll try this one. All right, so it's going to build a starting app for me. There it goes. At the blazing speed of Microsoft. There we go. Now I get a graphical panel. This is going to be a graphical app, and you can add controls. So we're going to view the toolbox and do a few steps to put some controls on here. It's View Toolbox. Okay. And there's the tools, I think, or where are they? Over here. Okay, here's the toolbox. Initializing, there it comes. Okay. So now I need to take a label control and put it on there. Common controls. Okay. Label. All right. So there's a label. And then I want to name it password and a text box and call it form 1. Okay, so label. And it's not letting me type on it, which double click. It is, it's just very slow. Okay. By double clicking, I went to the wrong page. And there's some way to get back to the other view. I may not be able to do it effectively. Somehow I got to the code view, and I don't know how to get back to the designer view. Is window, perhaps? Yeah, I think so. Yeah, there's the design view. Okay. So I wanted to rename this object, and I think I should just type on it. Okay, if I'd done it when I originally put it there without clicking away, I could have just typed in it. Now that I've done it, I have to go down here, and here's where you put in the text. Word, enter. There, that does it. Now I've got an object that has the word password. Now I want to put a text box control in there. So I have to bring back the toolbox, which is here, and get a text box, which is an input box, and put it on my field. Okay. And then I have to have a button. All right. And press enter. Nope, did it to me again. In this virtual machine and also trying to see the instructions, I'm having a lot of trouble here. Here's the design view. I want this button to say enter, and I might be able to do it here by typing and then pressing enter. Yep, that'll work. You see it's doing it. So now I'm just trying to make a box here. Enter a password and press enter. This is the visual structure of it, which is pretty clumsy, but now we can add the code. And so you do the code for the button. This is the code, and you double click the enter button to make it an active element. Double click it, and now you can put code there. And so it's going to look, and it's going to see whether that was put in top secret, and you win, otherwise you fail. That's the code. So we're making a very simple little game here, and now we're going to run the form, which is here. And you see down here it's compiling it and all that jazz. It's going to run it, and then it'll eventually, yep, here it goes, going through an incredible amount of effort for this simple task to load it up, presumably. No issues found. I think it's just running. And all these red boxes worry me, but anyway, I don't know why it's going so slow. It's supposed to pop up so I can see it. And I think it's probably doing that just at the blazing speed of Windows. Maybe it's already there in a different pane or something. No, I don't think so. Maybe it's in a different window. Here's design. Yeah, but they should be running the live one. And somehow I'm not seeing the results. Anyway, I'm not sure what's going on, why it's not working for me, but anyway, once you get it there, then you can see it go. And the point of this is, you can save the app. It's in this incredibly dense thing, and what you actually have is an exe app which runs in .NET. And that you created one here. That's all you're trying to do, is create a .NET app. And the next one is more interesting. We're going to reverse engineer an app like this. I don't know why this thing is freezing up on me instead of moving, but this is pretty common. It's a big, heavy program. It's very easy to fall off the track. Let's just go on to the next part, which is the more interesting part. You see how you make incredibly simple apps, .NET apps, and what's more fun is to take them apart and see how they work. So let's go to .NET Reflector. This is one of the tools to do it. And there's a sample app here, which I made using that program, Visual Studio. And when it loads up Firefox, I'll be able to download this thing. Okay. Yeah, Windows is always unbelievably slow. This is also Windows on ARM. It's not emulating or anything. It's just how slow Windows really is. Anyway, there, I've downloaded this app, and that's good. Now let's see if it runs all right. There it is. Double click it to run it, and Windows doesn't like it. I have to allow it to run. It doesn't recognize it as a trusted sort of commercial app. But if I run anyway, Now it may run or it may, oh good, it's running. Okay, so here's the glorious app. So if I put in SS and enter, I get fail. But if I put in top secret and enter, I get win. That's all it does. It's a simple password guessing game. But the interesting thing is how this works. And to see that, one tool you can use is Reflector. We'll use a different tool tomorrow. This tool is pretty nice, but you can only run it like once for a 15-day free trial. So I'm going to have to reinstall it on this machine, or install it for the first time on this virtual machine. Redgate. There's a free one tomorrow that works well too that we can use. All right, there it is. That's Reflector Installer. So I run that. And there we go. All right. And so I can load that app in Reflector. There it is, .NET Reflector. File and open, I think assembly. Let me check. Yeah, file, open assembly, and the file. Okay. The fact they said assembly made me a little nervous, but it really is called assembly for some reason. And there it is, my ed331.exe. That opens it, and there it is. And the way this works, which is also the way Java is, there's all kinds of preloaded system things. And down here is the new one you added. And it's a tree-structured, object-oriented code thing. So you've got all these pieces of the app down here and resources for the app. So you have to learn how to navigate this structure. And I've got a picture here of how to get where we want to go. We want to go into the form 1 and find the button 1, and then we'll find the code. That's the idea. So it is in the Windows Form App 5. Okay, and below the references in Form 1, which seems to be unlabeled here, but you can't have everything. Okay, there we are, Form 1, there we go. Form 1, and there's the button. Yep, and there. The point is, you can see the code here, and this code is completely readable. It's in a high-level language. I think this is in C#. And you can choose to view it in different languages. I can choose to view it in Visual Basic. This is what I mean when I say you're handing out the source code with your app, which emphatically developers do not understand. I did reverse engineering of hundreds of Android apps, and tons of them have secrets in the app code. Because these guys think they're writing C, and the attributed program doesn't have all that in there. They don't know you can, and you can also modify the source code of Android apps. And that's what we're going to do here. It's very easy to modify these high-level apps. And you can view the raw intermediate language. This is the partially compiled code that's actually used. This is the intermediate language. And if you look at this stuff, it looks like assembly code. This is assembly code-like structure here. But the strings are readable. Here's the top secret, here's the win, here's the fail. And so what it does is it loads this string, then it does some kind of comparison, and then it does a branch. And if something is false, it goes down and prints fail, but if it's true, it prints win. So this here is what makes you lose when you put in the wrong password. So all we have to do is change that one command to make this game operate differently. And so you can view the intermediate language code. This is the effective code, the heart of the game, that tells you if you put in the right password. And you can look up on Wikipedia the hex codes for intermediate language. And you will find that branch true is 2D, and branch false is the hex code for branch 2 is 2D. We want to change branch false to branch true, and branch false is 2C. That's all. So we have to find this pattern. I looked up it's 0A06 2C and something, and then 72. If we change that 2C to a 2D, we'll change the logic of the game to tell you fail on the wrong password to tell you win on the wrong password. That's simple. So we can do this with a raw hex editor. So this intermediate language object is incredibly small and simple. If we close all this, we can use HXD on it. So let's go find the game. It's in downloads. I'll make a copy in case I mess it up and break it. I'll call this hacked. And now I'll open that in HXD. So I'll launch HXD as just a raw hex editor, your simplest tool for manipulating files in a Windows system. Back in the early days, Computer Forensics, the only tool they had was Norton Disk Editor. And now I can open that file we're trying to modify, which is here in downloads. There it is. Okay, now I just have to find that pattern of bytes. And so I look for 0A06 2C. So Control F, hex values 0A6 2C. 0A06 2C. And search. And it occurs in various places, right there. And the one I want should be, there's more to the pattern. I need the 72, they don't have the 72 in the correct place. There's supposed to be a 72 right after the 2C. You skip one and then you see 72. So skip this and see 72, and the others do not have the 72, so it's the first one. So if I double click the first one, it should get, in fact, I'm at the wrong one. If I go to this one, 28A, yep, there it is. 0A06 2C, 1 byte, and then 72. And so all I want to do is change that 2C to a 2D. So I just type over it, 2D. It turns red to indicate I've changed it, and now I can just save the file to save my changes. And that should do it. Now this game should be a lot easier to win. If I run this game, and I tell it to run anyway, even though Windows doesn't like it, I wait for .NET to load, okay? And now if I put in the wrong password, as you enter, it says win. So that's how easy it is to reverse engineer. The same thing works with Android. It's incredibly easy to modify Android apps. And and also Java apps. I've done that too. If you don't like a Java app, you can just take it apart. It's just a zip archive. There was a Java app that was important, but it had an offensive picture, so I just unzipped it, took out the picture, put in another picture. It's incredibly easy. And this is something a lot of people don't understand, how a lot of coders code assuming you can't see the source code. This is a really bad policy because there are many ways to retrieve source code. Now, compiled C, it's somewhat hard, but another thing is people keep putting source code on GitHub after a while, and also there are often flaws in web servers that let you see GitHub source code that you shouldn't see. So it's a poor practice to put secrets into source code, but a lot of people do it. Anyway, so that's a little bit of .NET. You can see how that stuff works. And we'll have a lot more of this tomorrow. Tomorrow we get into malware analysis of a lot of categories. And we'll play with a lot of these different languages that are used to write malicious code and see how to take them apart and analyze their behavior. All right, so let me stop this one.